Question number 1 is implicit differentiation. That means we have an equation that is not explicitly y equals to fx but mixed. Both x and y are mixed. So first of all, what we have to do is we have to differentiate both sides. So it has to be d by dx of left hand side is twice x plus 3y squared plus 3x squared y equals to d by dx of 4x squared. So as we differentiate, 2x would be 2 plus now 3y squared. This is implicit differentiation. So when we do d by dx of 3y squared, it would be 3 and y squared would be 2y, and then we will have dy by dx plus now this portion 3x squared into y. This is going to be uv or product rule. This portion is u and this portion is v. We have to use the product rule for doing this. So that would be u, which is 3x squared, into d by dx of v, which is y, plus v d by dx of u, which is 3x squared, equals to, now this side is d by dx of 4x squared, which would be 8x. So now we can simplify. So 2 plus 3 to the 6 y, and we have dy by dx plus this would be 3x squared into d by dx of y is dy by dx plus y d by dx of 3x squared is 6x and equals to, we have 8x. Let's keep all the dy by dx on one side and send everything to the other side. So this would be 6y dy by dx plus 3x squared dy by dx equals to 8x minus this is going to be 6xy minus this is going to be 2. Therefore, if we take dy by dx common, it would be 6y plus 3x squared, and this would be 8x minus 6xy minus 2. Therefore, dy by dx would be equals to 8x minus 6xy minus 2 divided by 6y plus 3x squared. So we have an expression for dy by dx, and that's exactly what we are asked to do. But the gradient is not dy by dx. What we just found is an expression for the gradient. For finding the gradient, we have to put the value of xy. X is minus 1 and y is 1. So let me do it over here. At the point minus 1 1, dy by dx would be equals to 8 into x. X is minus 1 minus 6 minus 1, y is 1 minus 2 divided by 6 1 plus 3 minus 1 squared. This turns out to be minus 8 plus 6 minus 2 divided by 6 plus 3, which is going to be 6 minus 10, which is minus 4 by 9. In question number B, we have to find the equation of the normal. That's a concept from C1. Remember, the equation of a line that passes through the point x1, y1 and has the gradient of m is y minus y1 equals to m x minus x1. That is known as the point slope form. Now, first of all, we need to find the gradient of the normal, and for that we need a rule. So gradient of normal, that is reciprocal of the gradient of the curve, that is negative reciprocal, minus 1 by minus 4 by 9, which becomes 9 by 4. That is the gradient of the normal, and the equation would be y minus y1, which is 1. So the x coordinate is minus 1, y coordinate is 1, equals to gradient, which is 9 by 4. X minus x1 would be x minus minus 1. Now we have to express the answer in a particular format, so we need to simplify. Let's cross multiply. 4 into y minus 1 equals to 9 into x plus 1. Minus and minus becomes plus. So this would be 4y minus 4 equals to 9x plus 9. And it turns out to be minus 9x plus 4y minus 13 equals to 0. So that's the form ax plus by plus c. Now if you want to, you can also multiply by minus and it becomes 9x minus 4y plus 13 equals to 0. This question deals with integration by parts. Now this is the rule for integration by parts. It's a little bit like differentiation product rule, but not quite. First of all, we have u dv by dx and dx. So what u is going to be depends on order of preference known as LATE. L for logarithm, A for algebra, T for trigonometry, and E for exponential function. Now what we do over here is that, so first of all, we have integration of x sine 3x dx. So this is going to be equal to uv minus integration of v derivative of u dx. Since we have dv by dx, in order to find v from there, what we need to do is use the fundamental rule of calculus. So that means v would be equals to the integration of whatever expression there is. So we have to integrate this expression over here and then we will find v. And in order to find du by dx, we have to differentiate this expression. So let's get going. So first of all, LATE, A is algebra, so x is going to be u, and trigonometry falls after algebra, so this is going to be dv by dx. So by the formula, it is going to be u, since x is equals to u, so it's going to be x. Then we need v, since if this is dv by dx, if we do some work over here, if dv by dx equals to sine 3x, then v is going to be integration of sine 3x dx, which is minus cos 3x divided by the chain rule. D by dx of 3x is 3. So that is going to be the expression v. I'm not going to write plus c over here because we're going to write a plus c at the end of the sum. So this is going to be, v is going to be minus cos thrice x divided by 3 minus integration of, then we have v. So I'm going to write minus cos 3x by 3 in terms for v, and du by dx, if you differentiate x, it becomes 1. So that's the formula of integration by parts. That's the first line. The next line we simplify, so this would be minus 1 by 3x cos thrice x. Now this minus and this minus becomes plus, and we can bring the constant 1 by 3 outside. This would be cos 3x dx. So this would be minus 1 by 3x, same as x by 3, cos thrice x plus 1 by 3. Now the integration of cos thrice x is sine thrice x. So this would be sine thrice x divided by chain rule is 3. And since the integration is done, we can write plus c. So it would be minus 1 by 3x cos 3x plus 1 by 9 sine 3x plus c. For question number B, we have to do x squared. That means at some point we would be using the previous sum x sine 3x. Take a look. So what we have here is integration of x squared cos thrice x dx. Now it's a good idea to write down the integration as I. It comes in handy. So if I equals to integration of x squared cos 3x dx, so we know by LATE, so trigonometry comes later and A for algebra comes before. So u is going to be x squared and the remainder, whatever is left over, is dv by dx. So this is going to be u by integration by parts formula u v. Now since this is dv by dx, so integration of cos 3x is going to be sine 3x by 3. That is the integration of cos 3x minus integration of v. So v is going to be sine 3x by 3. Remember, this time dv by dx is cos 3x. That means if you want to find v, it would be integration of cos 3x by the fundamental rule of calculus, which says integration is the opposite of differentiation. So this would be sine thrice x divided by 3. So minus integration of v du by dx. So the derivative of x squared is twice x dx. So it turns out to be, if we simplify, 1 by 3 x squared sine thrice x minus, now this is 2, this is 3. We can bring the 2 by 3 constant outside and we can write x sine 3x dx. Now if you take a look at this integration, x sine 3x dx is something we did in question number A, x sine x 3x. So all we have to do is plug in the value. So we can write 1 by 3 x squared sine thrice x minus 2 by 3. Now let's plug in the value, minus 1 by 3x cos 3x plus 1 by 9 sine 3x, and at the end we can write a plus c. So if we simplify this, it would be 1 by 3 x squared sine 3x, this minus and this minus becomes plus 2 by 9 x cos 3x, then minus 2 by 27 sine 3x plus c.